Okay, so we have our first quiz coming up on Wednesday. And this first quiz will look like assignment 2. Assignment 2 was due early this morning. And what I'm going to do now is go over assignment 2 and in preparation for this quiz on Wednesday. Oh no, I'm sorry. We're on assignment 1, right? Oh, I thought I was doing something wrong. All right, yeah, the quiz is later, right? Or is the quiz coming up? Oh, the quiz is this coming Wednesday. And assignment 2 is due last night, right? Oh, so I had it right. Okay, so we do assignment 2 is due last night. Oh, this one, the manual one, right. So this is what the quiz will look like. Okay. All right, let's do this. Does this make sense? This is what we want to do, right? Let's prepare for the quiz on Wednesday. Okay. Which I need to write, so. All right, let's do that. All right, let's just work it out on paper. Notepad. All right, let's just go through these and do them one after another. All right, exercise 1. When the above code runs, what does it output to the console? All right, let's see. What does it output to the console? Well, we have to read it. We have to go through it and keep track of what? Keep track of the state of the variables. That's it. We just have to keep a mental record of what each variable equals, and then we just perform each instruction. So this is a very easy problem, but you have to know what to do. You don't just look at it and say 3, 4, 5. I mean, you can't do that, right? So you need to have a procedure. You have to think like the computer. And what the computer does is it executes one command after another, one statement after another. And except when it hits certain things like loops, then it's going to repeat something based on a condition. Or when it reaches a conditional, it'll do one block of instructions versus another based on the condition. All right, so we have I. We create a variable I, set it to 0, and then we hit this while loop. That means we're going to repeat the block of statements inside of it over and over again until the condition is false, the while condition, the condition that I have highlighted. So let's just keep track of I. I'm just going to put a little comment here and say that I equals 0, just so that we can do it in our heads, but let's just do it this way. That's just to show you what we're doing. So 0 is less than 7, so that's true. That means we execute the statements in the block. And here we have two operations. So we have the output operator and we have the multiplication operator. So what do we do first, the output or the multiplication? We do the multiplication because that has higher precedence. So we take 0, multiply it by 2, we get 0, and we send 0 to the output stream. So it's going to print 0. And then we increment I. Okay, let's make a mental record of that, or actually a record on paper. I is now 1. And we reach the bottom of the block, and so we return to the start of the block. Actually, no, we return to the condition. We need to verify. When we hit the bottom of the loop, we have to go back and check the condition again to see if it's still true. It is still true. I is 1, that's less than 7, so we print 2 times 1, which is 2. Now notice I didn't put a space there, so actually it looks like that, but on the quiz you can put a space there. And maybe what I'll do on the quiz is do something like this, just to, it's harder to read, but you know, it's easier to, that's how you would actually do it. I mean, if you wanted to see the numbers spaced out like that. And, all right, let me go back. So basically, we're going to keep printing multiples of 2 until I is 6. Let's suppose I is 6. If I is 6, then 6 is less than 7. So that's still true. And then we'll print 2 times 6, which is 12. So we need to make it up to 12. Once we print this 12, then we increment I, which was 6. Sorry, I should have it like this. Once we hit here and I is 6, and I becomes 7. And we hit the bottom of the loop, so we return to the top. We compare 7 to 7. 7 is not less than 7. So it's false. That means we exit the loop, and we're done. So that's the output right there. Now, if I did something like that, maybe you could do something like this, right? So when I is 16, you would print 32, right? And that would be the end. Something like that. I've never done this in a quiz, though, but I just thought of that you could, if I gave you a big number up here, rather than writing each value, you could just use ellipses. Okay, let's do the next one. Actually, let me undo that. That doesn't work. Let's do exercise 2. Just going to install that. Exercise 2. Let's do this one. So here we have a for loop. Well, actually, what did I ask for here? Rewrite the above code so that it uses a while loop rather than a for loop. So someone made a correction. I don't remember who it is, but I had this worded incorrectly a few days ago, and I changed that. So rewrite this as a while loop. So look, the loop variable here is I. And this is the initial declaration of that variable, just inside the for loop. And so then we have while, and then inside the parentheses there is the condition, the loop condition, which is here. And then this is what you do right at the bottom of the loop. And this is what you do inside, just within the loop itself. Actually, this is identical, isn't it? I must have wrote this down and intended to change it to make it a little different, but I forgot. Huh? I'm missing a semicolon, thanks. Because if you miss a semicolon, I'm not going to take off for that. You know, I'm not looking for syntactical precision. I'm looking for you to understand the concepts. All right. Let's take a look at the next one. Exercise 3. Here's the code. How many times does the body of the for loop run in the above code? This is the body of the for loop. How many times does this, the compiler ignores the comment, so it's really a single statement. How many times does that single statement run? What's that? Yeah, 100 times. No, it's not 99. It would be 99 if you started counting from 1. If I went 1, 2, 3, 4, but we're starting counting from 0. So imagine, obviously, we never hit 100, right? We never hit 100. We hit 99. So imagine if you started counting 1, 2, 3, like that, you do it 99 times, right? But if you started 0, 1, 2, we got to add that 1 for the 0. We started at 0. Now, this is not a trick question. This is, in fact, the standard form that you'll see a for loop in any language. This is the standard form. Programmers start counting from 0. And programmers start counting from 0 because computers start counting from 0. That's where it comes from. What's that? Oh, K, it is a little bit of a trick question. This says K doesn't have anything to do with that, right? Or I think what I was going to do is something like this. Probably that's what I was going to do. I don't remember. So you just have to keep track of, you'll have to look at this code and say, oh, K never changes, K is 100. That's probably what I meant to do. And similarly, I probably meant to vary this exercise so that it wouldn't be identical to exercise 1. Let's look at the next exercise. Here's the block of code. When the above code runs, what does it output to the console? Well, the numbers are getting big now, right? So I'm getting a little tired. I don't like to see 11, a 99. All right, so how are we going to do this? Well, we just read it. We'll read it like it's a story here. We create an I. We set it to 11. That's the opening line in the story. And then we hit this loop, and then we output I. So, well, we're going to output 11, or are we going to output something else? And I forgot what we were supposed to do. What does it output? Okay. So if we didn't do this, we would just print 11. But we're going to do something. And what we do is we're actually going to modify I. Okay, so we're not going to print 11. We're going to add 3 to I some number of times. So we're starting at 11. That means it could be, The answer could be, maybe we don't add I at all. Then it could be 11. Or maybe we add 3 once. That'll give us 14. Or maybe we'll add 3 twice. That'll give us 17. So it'll be one of these numbers, 11, 14, 17, some number k such that, oh no, we have some number 11 rather. Looks like that. Actually, it'll be the number of times we do this loop. That's one way to figure it out. Anyway, it's pretty straightforward. So we want the value for this expression that's less than or equal to 99, and it can't go, and then k can't go one more. So what would that be? Huh? We're doing 3k. We don't know how many times the loop runs. All right, let's suppose that k is the number of times the loop runs. That means we're going to add k3s to I. And this is the expression of adding, I starts at 11, and then we add k3s. This is the way I said it. We start at 11, and then we add k3s, where k is the number of times the loop ran. What's that? 30? 30 times? Let's analyze that. If the loop will keep running until I is less than or equal to 99. Let's see, when k equals 30, we'll have 11 plus 99, right? I'm sorry, 90. That's 11 plus 90, which is 101. So I will end up being 101 at the end. But this is just before this point. I is 29 times 3. Let's say 87, right? So that's 90. That's 98. See, look at this. Look at the sequence here. This will be, let's see, 90, 95. 98, 101. See, we start at 11, and then we keep adding 3. So we have that sequence. Each term in the sequence is equal to this for some k. So this I, when this I hits 98, and we return, and then we hit the, first of all, when I hits 98 here, we hit the bottom of the loop, we come back to here, and we compare 98 to 99. Now 98 is less than or equal to 99, that's true, and therefore we do this again. When we do this again, we add 3 to 98, and we hit 101. And then, so I is now set to 101. We hit the bottom of the loop and we come back to the condition. We compare 101 to 99. Oh, 101 is not less than or equal to 99. The loop condition is false. We're finished. And then we print I. when I is 101. So we print 101. Is that okay? That was a hard one, right? Or not? Was that tough? Huh? Not hard yet? Exercise 5. Exercise 5. When the above code runs, what does it output to the console? What is 1 divided by 2? Wait, remember, when you see that slash, it's one of two things. It's either integer division or it's floating point division. Is this integer division or is it floating point division? It's integer division because the numerator and the denominator are both integers. Both operands are integers. 2 is an integer, 1's an integer. Here, it's different. Here we have the denominator as a floating point number, so the compiler says, oh, that slash is going to be floating point division. So when we take 1 divided by 2 here, the result is guaranteed to be an integer, and the compiler does not generate code to round. It truncates. So it discards the fractional component. So it's going to print a 0. It's a 1 divided by 2. The fractional component is a half. That's discarded. It's a 0 plus a half. And then we'll print a comma and a space. And then we'll print 0.5. Or you can put 0.5. Is okay. Say it again. Yeah, that's good. That's good. In fact, because I won't give this exact question. Maybe on the exam I'm going to go like this. That one, right? That's the same thing. If either operand is floating point, if both are floating point or one of them is a floating point, doesn't matter which one. The compiler says it's going to be floating point division. So get the same result there. The same for this. The only time you're going to get truncation and an integer result is here, when both operands are integers. This is an operand. This is an operand. And this is called the operator. Whoops. Let's do the next one. This one's hard? When the above code runs, what does it output to the console? I++ is different than ++i. Those are different expressions. What does this output to the console? All right. So let's keep track of the state of the variables. Here I is 2. Here k, oh, this is going to be tricky. When this statement finishes, what does k equal? Well, what does that mean? So when the plus plus or the minus minus operator follows the variable, it means that that operation, that increment or decrement operation, is performed after the expression that it appears in is evaluated. So we want to first evaluate the expression in which I appears in. And then after we do that, then we're going to increment I. So this expression is evaluated and then assigned to K. So we do this whole thing, and then we increment I. So it's like a delayed increment. So K is what? Well, I is 2, and 2 times 2 is 4. So 4 gets assigned into K. 4 gets assigned to K, and then after that's done, I is incremented. Okay? And we don't go back and do this statement again. We only do this once, okay? We assign to K once.
So the K equals I, that I plus plus, it's still 2 before adding into K, before assigning into K?
This is 2 when we evaluate that multiplication. So we do 2 times 2. So I remains 2. The plus plus is not performed. So first we use the I in the expression in which it appears, and then we increment I after that's all over. So we take the 2, I is 2, we multiply by 2, we get 4. We assign the 4 into K. It's all done, finished. Now we're going to increment I. Now I becomes 3. And you see these expressions you see in many languages now. It's just a common syntax. JavaScript, C#, Java, those languages, and probably some others. And so when we get to this point here, we've got a similar expression, but this time we have the the pre-increment operator instead of the post-increment operator. This is the post-increment operator. This is the pre-increment operator. The pre-increment operator is the normal way to do things, which is to evaluate the increment first, then use it in this multiplication. But I is 3, and so this becomes 4. And then we have 4 times 2, which is 8. And then 8 plus K, but K is 4. That's 8 plus 4, that's 12. You want me to say that again? Repeat the last statement? Okay. Well, look at these operations. This operator has the highest precedence. This is the next highest precedence. This is the least. This has the least precedence. That means we're going to do this first. When we're done that, then we're going to do this. And then once this is evaluated, we're going to add the K. So you could do that actually. On the quiz, you can use parentheses and brackets or just parentheses. So we want to increment I. Remember, I is 3 at this point, right? Because we did these 2 commands already, these 2 statements rather. And when we get to the third statement, we need to evaluate this expression and then print it, or write it down in this case. So if we increment 3, we're going to get 4. And 4 times 2 is 8. Oh, I should have started with this. K was 4 the whole time. Sorry about that. And then we evaluate 8 plus 4, that's 12.
Actually writing it anywhere. So we just keep it in our mind. So the computer just keeps it in their mind that it's on the second one we increment it after we do that operation and it's here. And then but I is 3 at that point, right?
I is 3 when this statement completes.
And then when it goes to the next one, I is 4.
When it goes to the next one, I is 3. Oh, I see. No, I is 3 when it starts this. I is 4 when this component of the expression is evaluated. So the value for I is going to change as the expression is evaluated.
Okay, so you start off with the can I and get the 4 to get the K, and then how does I become 3 again?
How does I what?
How does I become 3 again? You start off with the
I becomes 3 as a result of this expression being evaluated in the second statement. This is just scribbling on the paper. You know, maybe it's better not to have that. Well, you just have to mentally keep track of what is I, what is K. What expression have I, what operation have I just performed? That's all you need to know. That's all you need to remember to evaluate this. What is I? What is K? What is the last operation that I just performed? Oh, and what is the... you need to remember a little more than that, actually. You need to know what... You know, what is... there's quite a bit to remember there, huh?
I got that one wrong. Can I go change the answer?
You can change the answer on the quiz. This is practice. Yeah, back there.
So
Every exercise is worth 10 points? Yeah, I think so. Is there 10 questions?
yes.
Yeah, that's right. Well, now you know, right? Now you know how to do this. So you missed a point, but the objective is not to get a point. The objective is to know, right? And now you know, so you should be satisfied. Back here?
you get partial credit?
Only if you get partial knowledge. No, I'm not kidding. No, for this problem, there's no partial credit for this particular problem. This is too hard to give partial credit for. So everybody gets confused on this one then, right? Well, you need to go to the book and look up, basically it was this, right? That's the problem, is understanding that. That's the problem. Plus getting used to thinking in algorithms, thinking like an algorithm. You don't think like an algorithm, but to think through, to read through an algorithm and to analyze how an algorithm works. All right, let's do exercise 7. Write a C++ program that computes the sum of integers 0 through n, where n is an integer entered by the user. Compute the sum of integers 0 through n, where n is entered by the user. So we'll declare n. You know, we don't need to initialize it. Yeah. So you create the n, read the n from the user. You know, you could say, please enter a number, but you don't need that. And now, what is the sum of values from 0 through n? You could use a for loop or a while loop, but what do you think the easiest is? I think. What do you think my opinion is about the easiest? No, for, because you know exactly how many times the loop is going to run. It's going to run exactly n times. So that's when you know, oh, I got a for loop. It's not a tricky. While loops are for complex conditions, and for loops are for doing something n number of times. So we need to do we're adding the sum of values 0 through n. So we'll have this variable to keep track of the sum. And we have to add numbers into it. So we add a 1, then we add 2, then we add 3, like that. And we do it up to n. So yeah, we do n here, actually. I was going to explain about that, but... Oh, yeah, maybe less than or equal to n. That's correct. That's correct. Yeah.
So what if you don't do it in the loop, you just use the mathematical formula?
Yeah, I know, because a lot of you are math majors, so you know this little tricky formula, n times n minus 1 over 2. Is that it? Yeah. So, I mean, I can't take off credit for that, but I want to. Because the point of the exercise is that it's trying to get you to understand looping. So what I do as a result is, I just thought of that, and I'm glad you asked the question, because I'm thinking, how can I make the problem tricky and complicated so that the math majors can't, just jot down that formula there? Because I want to avoid that. Although it's nice to see that you know that fact, actually, and can use it. So that's good. That's a very important expression, too. All right. Oh, so what are we doing here? We have a loop that, goes from 0 all the way up to n, including n. What do we do? Yeah, that's right. Sum is sum plus I. Be careful, don't say sum equals sum plus n. Maybe partial credit. If you put sum equals sum plus n, I might think, oh, it's just a typo, even though you're not typing. So maybe that would be partial credit. But so that's just like, I made that mistake. I left this out, right? That would be some partial credit there as well, right? But it's not the right answer. Those are the two forms of partial credit that I can see in that problem. We just compute the sum. We don't need to print it or anything like that, right? Well, that's good. You don't need to print anything. That's it. That's the program right there. That computes. No. This is good enough. I mean, obviously, what I want you to know here is how to write the loop, how to define that the fact that you need a variable called something like sum, and that you know how to constructs the loop and that does the correct thing with the variable. That's what I want to see. If you print it or don't print it. I would say print it out if I wanted you to print it out, but I didn't say that. Yeah.
What about iOS stream using namespace, stream and main and all that?
No, you don't need that. Right. No. This is what I want right there.
Question on that. Why do you need to define n and sum? Like,
Why do we define n?
well, n sum equals 0. Why do we need that?
Oh, because we need to accumulate the i's. How are we going to add up the I? How are we going to, once we get a 0, we need to store what we're accumulating. So we want to take 0 and add 1, and then add 2, and then add 3, and then add 4. Each time we add one more of these i's, we have to store it somewhere. We're storing it in a storage location that we are calling sum.
What she asking is, she asked if in n you don't need to make it equal 0 because people are going to put in a
Oh, is that what you're saying? You don't need to say n equals 0? I thought you said, why do we need sum?
I'm confused with the other program that we would write int. Well, int n, yes, because it needs to go to n. I'm confused on the int sum. Yes, you're explaining that we need to store it somewhere.
Yeah, exactly.
So by saying sum equals sum plus I, we add 0 and store it to sum. Then we add 1 and store it again to 2. Is that how it works?
Yeah, you can do it like, look at this. Let's analyze this. When we're here, sum equals 0. And now let's enter into the loop, okay? Then we have an I, and we set I equal to 0. And also before we go in there, we even have n. Let's suppose the user types in 3 for n, okay? So these are the 3 variables. The user enters 3, so n is 3. We declare sum and we initialize it to 0, so we have sum 0. And now we enter into the loop. And then we have yet a third variable I, which we initialize to 0. So we set it to 0 here. When we enter the loop, we create or declare the variable I, initialize it to 0 right there. That's the initialization section of the for loop. All right, so we're up, here's the story. The user entered a number, we created sum, we created I, we initialized sum and I. N is set to the value the user entered in. Now we're going to start the loop. This is the point that we're at in the story. So what do we do? Well, the first thing we do is we evaluate, after the initialization, we evaluate the loop condition. We have to compare I with n. I is 0 and n is 3. So 0 is less than or equal to 3. That's true. The loop condition is true. So we do the statements that are in the body of the loop. What do the statements say? Well, we have 2 operations. We have assignment. That's not equals like in math. Equals in math expresses a condition. And it's used for defining a set of numbers called a function or something like that, right? Or a relation. So in math, equals is a condition, is used to express conditions. Here, this is not a condition. And it's unfortunate, actually. If you look back to the history of computing, they had to decide what symbol are we going to use for assignment. A dot, a comma. What symbol should be used to represent the operation of assignment? And they decided to use equals. But what they wanted to use was an arrow. Because when they wrote pseudocode, they used arrows. They would say sum, and then they would have an arrow pointing left, sum plus 1. So add I to sum, and then assign it into sum. So when you see that equal sign, you should think of it as an arrow. But there was no arrow on the keyboard back then, and there's no arrow on the keyboard now either, right? So maybe they could have done something like this. You see that sometimes. See, it's not the relation of equality, it's the operation of assignment. So the operation of assignment has the lowest precedence in this statement. The operation here, the addition operation, has higher precedence. So we take what's in sum, which is 0. We add what's in I, which is 0, and we get a result which is 0. And then we take that result and assign it into the storage location which is named sum. So now sum becomes 0. And then when we hit the bottom of the loop, what do? We do this. We increment I. So that means I becomes 1. After we increment I, what do? We evaluate the loop condition. We have to compare I, which is 1, to n, which is 3. 1 is less than or equal to 3. The loop condition is true. So let's execute the statements in the loop, in the body of the loop. Once again, this is an assignment. We have an expression that must be evaluated, and the result is assigned into the storage location named sum.
So it's sum plus 1 goes back to sum, and then sum plus 2 goes back to sum, and sum plus 3 goes back to sum.
That's right. That's right. So we use sum to compute the next value that sum will become. So here sum is 0 and I is 1. This expression becomes 1. 1 is then assigned into sum. But we already used the 0 state of sum, and we don't need that anymore. Now we can assign into it. And then we continue that. Do you want to do one more pass through the loop, or is that enough? One more pass? So we just evaluated this statement. Now we get to the bottom. Now we're at the bottom of the loop. We have to go back and do the end of loop statement. Plus I. So we have to increment I. That becomes 2. This operation is now complete. Now we evaluate the loop condition. I is 2, n is 3, 2 is less than or equal to 3. That's true. The loop is true. The loop condition is true. Let's take what is in sum, 1, add it to what is in I, 2. That becomes, so this expression becomes 3. This evaluates to 3. And the 3 is assigned into sum. And that completes the evaluation of this statement. The execution of this statement, rather. Actually, you could say evaluation, too. And here's the end of the loop. Go back and increment I. Check the loop condition. Is I less than or equal to n? Yes, it is. N is 3. I is 3. 3 is less than or equal to 3. Do the body of the loop. Evaluate this expression, assign it into sum. The expression says take 3, add it to 3, that's 6, assign 6 into sum. Finished. Now we're at the body of the loop. Let's do this increment operation again. I becomes 4. Evaluate the loop condition. Is 4 less than or equal to 3? Oh, that's false. 4 is not less than or equal to 3. The loop condition is false. We're finished with the loop. Time to move on. There's nothing else to do. We're done. sum is 6. That's how, the user entered in 3, n didn't change. So 0 plus 1 plus 2 plus 3 is 6. All right, let's keep going here. Exercise 8. Write a C++ program that prints every number between 330 and 550 inclusive. That means, well, I got to print 330 and print 550. You do not need to compile or run this code. All code in this assignment is to be developed manually, right? So that's just reminding people how to run this. Print every number between these two numbers. So we want to do that, right? What's that?
Then copy the code from exercise 7. You change a few numbers.
Copy the code from exercise 7.
Yeah.
Yeah, you certainly when you look back, because I'm giving you a code example, so oh yeah, right, that's how you do a loop, right? So you could do it like that. Yeah, we could do a for loop here. We can do a for loop. We just want we want some number to range between 330 and 550. There it is. Right. You could do that, or if you wanted to, you can do this. I don't need that. This is good enough for full credit. Just a loop, right, with an output operation.
But there's no spaces, is there, between the numbers?
Once again, if you put that in there, that's great. But I don't need it. That's what I'm saying. I just want to see that you understand about loops. This is for formatting detail to make it clean. Yeah.
The same thing if we write I less than 551.
Yeah, that's acceptable. This is full credit as well. This is fine. That's good. That's great.
What about
Huh?
the
While loop is okay too. While loop is good too. You can do it like this. Whoop. Does that work? That doesn't work, right? See, when I write a while loop like this, I usually forget the plus plus n, and then I have to debug. I get an infinite loop, right? And the program freezes because we're just printing n, and it never increments n, so this condition is always true. All right, we better move on here.
So is that one wrong? The second one you printed, or is that like the same thing as?
This is fine. This is the identical.
Oh, okay, that's good.
Yeah, it's not identical, but it gives an identical output, so it's good enough. And here's exercise 9. 2 more to go. Let's do these fast. Write a program that prompts the user to enter a number between 3 and 12 inclusive. If the user enters a number inside 312, the program displays. I'll edit that later. Good number. Otherwise, the program displays bad number. So it's conditional. So it's a 3 and 12. So let's do this. It said prompt, didn't I? I did say prompt, didn't I? Prompts the user. So I'm asking for prompting the user. So enter A. Then enter B. You know, I probably wouldn't take off for this, but you do need to declare A and B. Or maybe I will take off, I'm not sure. But you should declare A and B. And then we have the condition. If, so we want A to be between 3 and 12 inclusive. So if A is less than 3, or A, wait a minute, it's only one number, I'm sorry. You know, I'm thinking about something else. Enter A, there it is. But A is not good, right? Maybe, I mean, A is okay, A is fine, but just I'll use X. But X sounds like a float, doesn't it? Maybe N. N. So if N is less than 3, or N is greater than 12, then print bad number. And I'll accept bad. Else, it's good. Does that look all right?
Professor,
Yeah.
I do have a question. In the if right there, if I put two and signs there, will that still work?
No.
No?
This is always false. This is the opposite of a tautology. It's what's it called when a statement is always false? What's the opposite of a fallacy?
Is a statement that's always true for any value of x.
No, this statement is false for any value of n. Give me a number n that's less than 3 and greater than 12. What number n satisfies that?
But you can change sign.
Huh?
You can change the sign like n is might be greater or equal to 3 and smaller or equal to 12.
Oh yeah, yeah. So you want to say what's the equivalent for using or, right? Let's do like this. So we want to use and here. This is an equivalent. If n is greater than or equal to 3 and n is less than or equal to 12, then what do we say here? Then it's good. Otherwise it's bad. So it's kind of like the reverse. So either way is fine. You can do it that way as well.
What you cannot do it like with the n sign. 3 is less than n, less than or equal to n, less than or equal to 12.
Yeah, let me see. So you cannot do this. This will not work. Oh, not God. All right, let's get this done. We only have a minute. Exercise 10. We have a block of code. The above code prints odd number when the user enters an odd number. Write the code so that it prints even number when the user enters an even number. So I'm going to rewrite this. So we read the number, and then we have the condition. If I divided by 2 equals 0, that's an even number, right? Then we want to print even number. That's it.
Or you can also plus 1 to I before you divide by 2. And
Yeah, you can do it different ways, but I think this is the shortest, right? Then we don't have to add I. Why? We don't need to add 1. Okay, so the quiz is coming up, right? Wednesday. We'll have the quiz, and it'll look just like this. Yeah. Huh? That's a modulo. Mod. M-O-D. U-L-O. Modulo. Huh?
percent sign on the keyboard.
Oh yeah, percent sign. That's a percent sign. Is that what you were asking? On the keyboard, a percent sign.